Hey there, welcome to Sigma notation. And I'm going to explain a little bit about what this notation is. And I've got a little bit of an example sitting right here on the page. And it looks pretty interesting. Actually, it's from the Greek letter sigma. And what it is, it's how we can, sort of a short, compact way of writing a sum of numbers. So I don't know if sigma is maybe Greek for some or whatever the case may be. But anyway, that's what it means. And I've got one set up here. I'm just going to sort of walk you through how this works. Okay, so here's what we're going to do. K here is called a counter, and it starts with a value of 1. So the first thing I do is I plug a value of 1 in to this little kind of generator here. This is how the terms get produced. So K has a value of 1, and I put it in here. So this is now K1, so value of 1 plus 1. Okay, so that's when I plugged in the 1 for K, in where the K is, I get 1 plus 1. Then what happens is, because this is a sum, you're going to add your next term. Now your next term is K gets bumped up to a 2. Okay, these are always, it always goes up by full steps. So it goes from 1, now it bumps up to a 2. And so I'm going to put a 2 in where the K is. So my generator produces 2 plus 1. Okay, so that's my second term in the sum. And so plus. And now K gets bumped up to 3. And you notice there's a 3 on the top here. And that means that's the end of the road for K. This is going to be our last term. So we put a 3 in there. So we get 3 plus 1. Okay, so this is the expanded version of what this little sigma notation represents. And if you want to, you can get really fancy and actually work this thing out. It's a sum of these numbers. And it just happens to equal, looks like 9. Now, that isn't the important part. It doesn't really matter what our answer is. It's understanding how this sigma notation works. And again, I'll stress it, it's a compact way of writing out the sum of 2 plus 3 plus 4. So let's look at another sigma notation example. And might be a little bit more complicated. Maybe our little generator might be doing something like this. Maybe it's saying K squared. And maybe we'll not start at 1. Maybe we'll start at 4, and we'll go up to 8. So what would this look like if I expanded it out? Well, my starting value for K is 4, so I put a 4 in here, and it gets squared. Well, actually, let's write it all out. 4 squared. Okay, then plus, because sigma is a sum. Now K gets bumped up to a 5, so we have 5 squared. Plus, and now it's bumped up to a 6, so 6 squared. Plus, then it's bumped up to a 7, 7 squared. Plus, finally, because there's an 8 on the top, our last term is 8 squared. Now again, if we want, we can work these out. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and lastly, 8 squared is 64. And if I want to, I can even add all these numbers together, and I think, if I am not mistaken, we get 190. So that's a couple of cases of sigma notation. Now, before I clear the screen, sometimes the questions ask how many terms are there. And let's just look at these two examples here and see. Now here we had 1, 2, 3 terms. And K started at 1 and went up to a 3. Okay, now what about down here? Here we had 1, 2, 3, 4, 5 terms. K starts at 4 and ends at an 8. Well, here's how it works. Let me show you with the bottom one here. You take the top number and you minus the bottom number from it. But as you can see, that's only 4, and we know there's 5 terms. So you got to add 1. And that's because you're including both the 4 and the 8. And that's why you have to add 1 to that. So that gives us 5 terms, the correct number of terms. And you can see up here it's going to work just as well. 3 minus 1 plus 1. So that's going to leave us with 3 terms, which is correct. Okay? So sometimes sigma has a really strange way of starting. Let's say, for example, you had something like this. Maybe you had 14 at the top, and they decided, for whatever reason, we're going to start at -2. And you're trying to figure out how many terms there are, and we don't even care what the generator here is. So what would I do for the number of terms? Answering how many terms. Okay, well, top number is 14 minus my bottom starting number, and then I got to add 1. So this is going to be like 14 plus 2 plus 1. So it looks like 17 terms. Okay, so if ever you're wondering how many terms there are, that's how you do it. Pretty simple. The next challenging thing with sigma, and it's really our last example talking about sigma, is sometimes you want to start with some sort of a bunch of numbers added together, and you want to write that in a nice compact sigma kind of way. So in this example, somebody has given us the string of numbers here, 5 plus 6 plus 7, and we're going to write this using sigma notation, using sigma. Okay, so I got to rewrite this, or write it, using the sigma notation. Okay, well, I'm going to need sigma here, and let's see, probably the easiest way to start our counter is at 1. I mean, you can actually start with whatever number you want, but sort of typical, you start with 1. We also know we want to have 1, 2, 3 terms, so that means we're going to want to end with 3, so that we get 1, then 2, then 3. Now, how are we going to turn this into a 5 if the first value of k is a 1? Well, I think this one's pretty straightforward. You just take whatever k is and add 4 to it. I don't think there's much more to it than that. Let's just check to see that it works. If you plugged a 1 in, you'd get 1 plus 4. So there's our first term. Okay, and then it's plus. Second term, k is 2, so we'd have 2 plus 4. And I think you can see pretty quickly, hey, that's giving me 5, that's giving me 6. I think we did it correctly here. And the last one, k is 3, so let's just check just to be sure. 3 plus 4. Yes, the last term is 7, which is kind of what we were hoping to see. So it looks like 5, 6, 7. Yippee! There's our answer right over here. It's all written out with sigma. All right, well, that's a pretty good beginning as to what sigma is. It can get a lot more complicated, but that's a good start. So we're going to stop right there.